Okay, so chapter 8 talks about applied networking. And here we want to look at how to connect a computer to a wired and a wireless network, how to explain the purpose and characteristics of an ISP connection technology, and then how to explain cloud concept and network host devices or services. Now, we will also explain how to perform preventive maintenance on networks using common techniques. And then we explain how to troubleshoot a network, and then we end chapter 8. Good. Now, networking cards are used to do wired connections. So a wired network interface card is required to connect to the network. Now, after it is installed, you need to do some IP settings at the TCP IP properties. And then you need to configure the IPs either manually or dynamically. So the IP address is whichever uh, class of the IP that you are using on your network. You come into the TCP IP settings and then you put them in. So you can also configure advanced settings such as speed, duplex, and then wake on LANs. What is speed? Speed is speed is the rate at which something moves or operates, or is able to move or operate. That's a speed. So if you want to configure, you can configure the speed or the rate at which a particular packet moves through a network. And then duplex. Duplex has to do with a two-way connection. So we have differences between duplex. We have the half duplex and a full duplex. So a duplex communication system is a point-to-point system composing of two or more connected devices. So duplex systems are employed in many communication networks, either to allow for better still, duplex communication system is a point-to-point system composed of two or more connected parties or devices, right, that can communicate with one another in both directions. So duplex systems are employed in many communication networks, which is either to allow for a simultaneous or two-way transmission or simultaneous communication in both directions between two connected parties, or to provide a reverse path for monitoring and remote adjustment of equipment in a field. Now, a better example is what I'm going to give you. When you when you terminate a patch cable, let's say a straight through cable, inside the twisted pair cable, you have 8 wires. Now, the first and the second wires transmit data, and then the third and the sixth wires also receive. So one side, 1 and 2 will send. That is one transmission side. And then for the receive, 3 and 6 will also use the other 2 lines. So we say that this is a duplex connection. It has a full duplex connection when one side is using one line and the simultaneous receive also uses 2 lines. So in cable termination, for that matter, twisted pair cables, you have 1 and 2 sending, 3 and 6 receiving, and 4, 5, 7, and 8 are dormant cables, which could also be used for different connections. So one-sided communication is when only one send, and that same medium is what used to receive. And then a duplex means that they are two-sided. So you can configure duplex. So if you want to talk about the networking card and then the networking cable, you can configure how data is sent and received at the same time simultaneously on different type of cables. You can configure that in your TCP/IP settings. And then you can configure other types, the wake on LAN, and then the quality of service. And then to connect a network, attach a straight through cable to the network interface card, like we are seeing here. And then the other end connects to a router or a telecommunication port that is wired so that the data will reach the router. Good. And this is the graphical user interface of a particular router setting. So for wireless connection, you configure the router with the following. The network mode. So the network mode you can set to 802.11 standard, which is the Wi-Fi. And then you select the network name. So the router is a wireless router, which you can also configure on the MiFis you have been using, or even your phones. So the network SSID. The SSID is what we call the service set identifier. Now, this service set identifier advertises a particular broadcast for users to know that that particular hotspot or that particular device is available for connection. So sometimes when you want to search for a particular network, you see the name, maybe KTU Wi-Fi or KTU uh, uh, administration or KTU FM. And that is what we call the service set identifier. That is what is used to broadcast the availability of that particular device for those who want to connect. So the name you give to it will determine what name. So when you come to my end here, you see that all my Wi-Fi connections are KNTAGH, Kwaps Network Training Academy. So that when you want to join, you just look at it and then you join. If it demands for a password, we have whitelisted you, you can join. So that's what we call the SSID. And then so the SSID name must be given. And then the channel, which is which is important when there are multiple access points in the network, must also be given. And then you need wireless security, and that is the Wi-Fi protected access, Wi-Fi extensibility protocol, or whichever one you want to use. And then the common one and the better one is the WPA2. You put in a password so that anybody who has seen the SSID and want to join will be asked the WPA2 password before that person can join it. Now, sharing. All Windows computers on the network must be part of either a domain or a work group. The last time or the previous times I have met you, I've talked about a domain. I think even in class, I told you that when you come to Kwame Appiah's domain, you see Kwame Appiah's wife, you see his son, you see his daughter, you see, and anybody who you can find in the vicinity of Kwame Appiah's house. is related to Kwame Appiah in a way that makes him become available in that vicinity, and therefore it's part of Kwame Appiah's domain. So when you talk about a domain or a work group, they are computers of like minds that are finding themselves in a particular network or in a particular group. So in computer networks, you can set up a network group, which you call the work group, or which you call a domain, where when you add a particular person to a domain, we can use network management 2, level 200, 2C and D, your class. And we say that every member of that class is in a particular domain, and that domain is the network 2 class. And therefore, there are certain things you people do together, and there are certain things you people synchronize. When there's a lecture, like we are having a lecture, because all of you are in a particular group and are on a common course, when another person in your class calls you and said that I didn't have the video, I didn't have the notes, and you send it to the person, it becomes relevant to the person because that person is a member of that particular group. Now, if the person is in accountancy, it will be the notes will be irrelevant to that person because that person does not share the common values or the objectives of the networking class group, and therefore it will be irrelevant for him. So the accountancy class level 200 also have their own group that identifies them. So in the same way, computers must be in a work group so that when you want to look at people who are members of your network, when you go there, you see. That's why you go and see Acrofi's computer, you go and see Stanley's computer there, and then you can begin to interact or share files or share folders. And if you are not in the same work group or the same domain, you cannot be sharing. So before computers can share resources, they must be in the work group. So you have to map local drives in a way to be able to access a single file, specific folders, or entire drive between different operating systems over a network. So if we are in the same work group and I'm using Windows 10 and you're also using Windows 20, we should be able to share a file together, irrespective of the version of the Windows we are using. Even if it's Linux, we should be able to share a Linux between a Windows application, and then we should be able to share the file. And then so you have to determine which resource can be shared over the network and the type of permissions that you give. So you can choose to share uh, information to a group of people even in the work group or to everybody in the work group. And then the kind of information that you can share or that can be shared and all that. Now, what we are doing here, because I sent you the WebEx meeting, all of you are in my work group because you are in the you are in the group. That is why if you click on the link, you can join me. Now, I can control you. I can show you. I can go into my settings and make sure that I disable everybody's video. I can make sure I disable everybody's voice and all that. Because all of you are in the work group, I can affect you, and then I can have a control because I am the host. And if somebody is in another work group, I cannot have a jurisdiction over that person. So what you can share, I can determine what I will share to you, what you have access to, and I can determine what you can share. When I do all those settings, you might not be able to do certain things, and you'll be able to do certain things. And if you have to share any information, I will determine which one you have to share and or not. And all these things can happen when we are in a work group. And then we have what we call you have to determine which resource can be shared over the network and the type of permissions users will have to the resource. So read, the user can view data in files and run programs. The user can read, the user can change, the user can add files to subfolders, like I've explained, and full control. The user can change permission of folders and files. So there are ways I can also give you, all of you in this work group, in this networking work group, uh, either to give you permission to become the host or permission to control the network and decide what to do and all that. All those permissions are there, and it's only when you are in work groups that you can affect all those people. Now we have what we call a VPN. A VPN is a virtual private network that connects remote sites or users together over a public network like the internet. So, Ghana Telecom, or what do we call it, Vodafone, will come and solve a problem in your broadband at home, and then through the internet, he can do the settings in your home and then acknowledge the fact that he has finished the work. So a virtual private network is a network that allows members of the organization to have access to the organization's operations and core network, even away from home. And those people that use such services are what we call the telecommuters or teleworkers. Now, when connected to the corporate private network, users become part of that, and the resources as if they were physically connected. Now, remote access users must install VPN clients, yes, on their computers to form a secure connection with the corporate and private network. Now, before I could allow you to be part of the WebEx meeting, I told you to download the WebEx meeting application. And so it's the same way. A teleworker will need an application to be able to connect to his home network and work in a remote area. Now we have what we call the remote desktop that allows technicians to view and control a computer from a remote location. And then we have remote assistant that allows technicians to assist customers with problems from a remote location. Now we have DSL connections, uh, which uses the existing copper telephone lines to provide high-speed digital data communication between end users and telephone companies. And this is an ISP technology that can be used to provide internet service from the ISP to a client. And then we have what we call the line of sight wireless internet, as which is always on, that uses radio signals for transmitting internet access, line of sight. And then we have the cellular technology that enables the transfer of voice, video, and data. And that is what we are using with our telecoms. The cellular services that you make calls, that you are able to go onto the internet and able to share data. And then we have the cable, which uses coaxial cable lines originally designed to carry cable television. Yes, some of our cable TVs, like the multi-choice and stuff like that, some of them even have internet connection. Some of them communicate with you when your time is up. They send you a message. Some of them you subscribe internet from them and use them to browse. Some of them give you internet to be able to use certain applications on DSTV to be able to save certain videos, to be able to schedule certain videos and all that. And that is what we call the satellite connectivity with the use of a DSL connection or the cable. And then we have satellite as an alternative for customers who cannot get the cable DSL connection. So the satellite is also in use. And then we have the fiber broadband, which provides faster connection speeds and bandwidth than the cable. So the fiber broadband, you see that people who stay around Koforidua, Adjacent area, which have the fiber connection around their area have access to the fiber broadband. It depends where the fiber optic connection is passing through MTN. So the people in those areas are able to enjoy the fiber broadband. And even the fiber broadband that comes to campus for internet connection is this service. Now we look at internet technologies. We have what we call the data center, which is a storage and processing facility run by an in-house IT department or leased off-site. So data center has a lot of service with a lot of hard disk drives that are keeping a lot of information. The data center could either be owned by a particular facility or it could be outsourced. So the IT department or a lease offsite. So there are people who are keeping just data centers to make sure that they store information and other services for some particular organizations and stuff like that. And Huawei as a company has become a data center and the operation managers for almost all the telcos in Ghana. And then we have what we call the cloud computing, which is an off-premise service that offers a demand access to a shared pool of configurable computer resources. So cloud computing, they give you remote storage, they give you remote application and services. So it could either be for a particular organization or it could also be outsourced. There are companies that are providing cloud activities. When you sign in to with Apple, they have the Apple Cloud, which provides storage for information that cannot be stored on your hard disk or on your memory. And when you use Google, you have the Google Drive, which is also a cloud storage. And then so many companies are providing cloud services. Now, there are three main types. There are three main types of cloud service models. We have what we call software as a service. We have what we call platform as a service. And we have what we call infrastructure as a service. Now, what is software as a service? Now, this is a method of software delivery and licensing in which software is accessed through a subscription rather than bought and installed on individual computers. So software as a service is a method of software delivery and licensing which software is accessed online via a subscription. So you don't need to go and buy a CD to run it. You subscribe to it online and then you pay subscription for it rather than bought and installed by on an individual computer. So software as a service, if you download WhatsApp application and then you subscribe to it, terms of reference, terms of agreement, and all that, and then you are running it and you use it as a subscription. It's a software as a service. It's a software as a service, and we have so many of them which we can talk about. And then platform as a service, which can also be called application platform as a service or platform-based service. It's a category of cloud computing that provides a platform allowing customers to develop, develop, to run, and to manage applications without the complexity of building and maintaining the infrastructure, typically associated with the developing and launching an app. So, platform as a service simply means that you provide the platform to customers, right? To be able to develop, to be able to run, and to be able to manage the application without any complexity of building and maintaining the infrastructure. And then we have what we call the infrastructure as a service. And infrastructure as a service is a model for centrally putting in and collecting any type of log files coming from any given source or location, such as servers, applications, and devices. So another name for infrastructure as a service is logging as a service. This has to do with logging information. So any information, any uh any logins, right? That is made from any log files, any from anybody from any point of the network, anybody who comes in. That service is provided to be able to look for the location of that person, the person who logged in, and the applications the person used. So infrastructure as a service is a typical example of what happened in KTU when they were able to investigate and see that people were entering the system and manipulating data and pilfering funds from the accounts and all that. And that is an example of infrastructure as a service. So all the logs over a period, right, they were able to recoup all the logs, right? So all the logs are kept in a particular cloud computing facility so that at any point in time you can go and find out who came in and who went out. And that is what we mean by infrastructure as a service. So the four cloud computing deployment models are the private, the public, the community, and the hybrid. Now, networked host and services. Now we have what we call the dynamic host configuration protocol, which is the automatic assignment of IP addresses to host on the network or dynamically assigning IP addresses. It takes two forms. We have what we call the DHCP offer, or we have what we call the four-way handshake. The four-way handshake. So the DHCP discover, the DHCP offer, the DHCP request, and then the DHCP acknowledgement. As time goes on, I will explain what we mean by four-way handshake. So simply, this is a client and this is a server. It is a server that provides the addresses to a client, right? So the DHCP, the client assumes a DHCP discover, right? And then the client assumes a DHCP discover or discovers what we want to discover if there are DHCP services from the client, from the server. And now the server gives an offer, the DHCP offer, which is the assignment offer to the client. Then now the client comes back to request the service. Now, when it requests the services and the services are given to the client comes to acknowledge that truly I have been assigned an IP. So that is what we call the four-way handshake. There's a handshake when you discover there's an offer, and when the offer is requested, there's an acknowledgement, and when the offer is given, that's what we call the four-way handshake. So domain name service is the method of computer or the method that computers use to translate domain names into IP addresses. What is a domain? What is a domain name? I will explain what a domain is. And when you have an address like www.ktu.edu.gh, The www means World Wide Web. The KTU is the domain. So each domain has its members. So if I'm a member of KTU domain, that is why my email address is kwame.appear@KTU. That means that Kwame Appear is a member of the KTU domain .com or .edu. The edu means educational, which means it's an educational domain. If it's a .com, it's a commercial domain. If it's whatever, and the suffixes will show the kind of domains they are. So www.ktu.edu.gh is the email address of KTU, which means that at the worldwide activity, when you type it, it should go and find KTU domain, which is what? An educational domain. So if I'm a member, I become a member of the domain by being at the domain. And then these domain names are, for all these domain names are they are used to translate or resolve IP addresses of an organization. For example, KTU might have an IP address of 192.168.1.4. It's just an example, our institutional IP, right? But because in the address bar we cannot readily know the KTU IP address, that is why they have given KTU an address which we call the domain name www.ktu.edu.gh. So as soon as you type the www.ktu.edu.gh in the address bar of a browser, it quickly goes to resolve with the original IP of the organization, and then it brings the information. So the domain name services are used so that individuals can remember and locate particular networked organizations and their servers by resolving the names with the IP, so that they can be a query to have an information from the particular organization's server. And then we have the HTTP, which is the Hypertext Transfer Protocol, which are used by hosts to access web resources. Now, as soon as you sit by your machine and you go and type www.ktu.edu.gh, you see that automatically HTTP will come and add at the address bar. Now, that protocol is in charge of web services. So anything you have to do when you are browsing or you are obtaining web activity, it is the protocol that takes care. Now, we have what we call the file transfer protocol that allows hosts to transfer data between a client and a server. So secure file transfer operations which include the file transfer protocol secure, which is FTPS, and then a secure shell, which file transfer protocol, and then a secure copy, which is the SCP. And then we have the simple mail transfer protocol, and then the post office protocol, the internet message access protocol, and are the protocols that are used to send and receive email. And then networked hosts. Hosts need a variety of services to securely access the resource of a network. And so we have the print services, which enable multiple computers to access a single printer. And then we have the proxy services, which are popularly used to act as a storage or cache for web pages that are frequently accessed by hosts on an internal network. And we have authentication, authorization, and accounting, which is a way to control who is permitted to access network. You authenticate. And then when they do, while they are there, you authorize. And then you track what actions they perform while accessing the network. So that is the AAA. And then we have the IDS systems, which is the intrusive detection system, which passively monitor traffic on the network, while intrusion prevention can detect and immediately address a network problem. Then we have the Universal Threat Management, the UTM, which include all functionalities in the intrusion detection system and the intrusion prevention system, as well as the stateful firewall protocols. So, so this is the user who, through the cloud, goes through a router and wants to enter into a particular system. And then you have an intrusion prevention enabled sensor in the network that prevents uh, access to the network, and then it sends it to a bit bucket, or when it allows it, it sends it to a particular management console. Now we want to look at the common preventive maintenance techniques used for networks. Common preventive management techniques. Now, preventive management techniques include the condition of cables, network devices, servers, and computers to make sure that they are kept clean and are of good working order. The first thing to do is to develop a plan to perform scheduled maintenance and cleaning at regular intervals. And then you inform the network administrator if you notice any of the issues or any of these issues to prevent unnecessary network downtimes. Basic network troubleshooting. The first thing is to identify the problem, and that is the first step in the troubleshooting procedure. And then you have to list open and closed-ended questions, which is useful. And then you establish a theory of probable cause. What is causing the problem? Now, based on your answers that you receive, and then a list of common problems can also be useful in determining the probable causes. Now, after you have gotten the list of probable causes, you have to test your theories to determine the cause of the problem. And then a list of quick procedures to common problems can also help. Then you establish a plan that will help you to resolve the problem. So a plan of action needed to resolve the problem and implement a permanent solution. After that, you apply, or sorry, you perform full system check and then implement preventive measures to avoid future problems that will reoccur. Then the last thing is to document your findings, and your notes must be documented. And then the log can be helpful for future references. And it is out of the logs that you can have frequently answered questions to solve simple issues when they come up. Now, network problems can be attributed to hardware, software, and configuration issues. So some of the common networking problems could be issues that has to do with networking cables that are damaged or unplugged. You can have legitimate users that are having denied access or denied remote access. And then you can also have devices that lack sufficient addressing information. And then you also have users that cannot map a particular drive to share a folder and a network on a network. So this is it for chapter 8. The chapter 8 summary is there, and then you can look at it. Each device must have an appropriate addressing system in order to access network resources. You have wide access attached to the network and uses internet cables. Mapping of local drives are useful. VPNs are useful that to allow for connections over a public network. Remote network allows network administrators to remotely control the computers. And then examples of broadband technologies are the DSL, the cable, the cellular, and then the line of sight wireless connectivities. And then you also have data centers and facilities that will also provide storage services. Now, cloud computing also use data centers to provide cloud services in a variety of deployment models. And then you have network host devices or services, which include the dynamic host configuration protocol, which we have come to establish that it has a four-way handshake. And then we have the domain name system or the domain name service. We have the hypertext transfer protocol. We have the file transfer protocol, simple mail file transfer protocol, or simple mail transfer protocol. We have proxies, we have authentication, authorization, and accounting. We have the intrusion prevention systems and then the unified threat management. And then we crown it by looking at how networks require a systematic preventive maintenance. And that is the most important aspect. And normally with your network maintenance course, you need to know what goes on before you apply the maintenance procedures. And then troubleshooting methodologies. Okay, thank you so much for being around.